Good day, viewers all over the world. My name is Engineer Yemi Opeshade. Another opportunity for us to communicate STEM, and we are communicating STEM in the area of mathematics, and in particular, we are looking at another aspect of sequence. Sequence which has to do with ordering or patterning a number is very important. So we are looking at geometric sequence. Sequence is the listing of numbers such that there is something common. That thing that is common can be a common difference, but can be a common ratio. But for geometric sequence, it has to do with something that is having high multiplying effects as the listing continues, or a reducing high multiplying effect. So it can be increasing or reducing. So for geometric sequence, we talk about common ratio. R. Okay, here we talk about common ratio between the elements that are being listed. For example, I have this 5 minus 10, 20 minus 40, 80. Now, if this is a geometric sequence, it means that there must be a common ratio for this listing. What does that mean? Now, this minus 10 succeeds this 5. This 20 succeeds this minus 10. That means comes after minus 10. Minus 40 comes after 20. So to find a common ratio, you pick the successive one, minus 10, to the preceding one, 5. Let's go that equals to this one, 20, to the preceding one over minus 10. Let's go that equals to pick minus 40, to the preceding one, 20. Then lastly, this 80 to the preceding one, minus 40. If you get the same result, it means this is a geometric sequence. Now let's see. 5 here 1, that's minus 2. This minus 2. 40 divided by 20, there's a minus there, that's minus 2. 80 divided by 40 with the minus, that's minus 2. So this is a geometric sequence. Okay? So the multiplying factor is what? Minus 2. It means if I want to get the next one, I just need to multiply by what? Minus 2 by what? 80, it will give you minus 160. The next one, I will multiply minus 160 by minus 2 again, it will give me plus 320, like that. Is that clear? Because this common ratio becomes the multiplying factor. To get the next one, you multiply by the common ratio. To get the next one, you multiply by the common ratio. Okay, so that is how to get extra terms in a sequence. Now, that's like we did in arithmetic sequence. The first term is A, the so-called first term. First term is A. Then this is first term, second term, third term, fourth term, fifth term, and so on and so forth. Okay? So we already know how to get our A from this. Now, our common ratio. So from this now, we find out that the common ratio is A is 5. The common ratio is minus 2. Now, let's say I want this question now. Find the 200th term of the sequence. The 200. That means if I keep on listing this, which one will be at the 200th position? That can be very long. Please bring it here. That is why these formulas are there. You can use this n term, A equals to R raised to the power n minus 1, to find any term. So in this case now, you are looking for the 200th term. It means n is 200. So you use that formula, which is Tn equals to A R raised to the power n minus 1. Is that clear? Okay, now this will be equals to A is first term, 5. Dot common ratio is minus 2. Okay? Then n is 200. 200 minus 1. So this will give us 5 dot minus 2. 200 minus 1 is 199. So that means minus 2 in 199 places. It doesn't be too much for you to multiply. Minus 2 times minus 2 times minus 2 times minus 2. So you can leave your answer like this. Is that clear? So the n term that will be next at the 20th position, 200th position will be this. Okay. Thank you for that. Again, there's another formula you need to know here. There's another formula you need to know. For finding the sum, there are 3 formulas for finding sum of a geometric sequence. This first one, a bracket r raised by n, everything minus 1 over r minus 1. The other one is a bracket 1 minus rn, okay, over 1 minus r. Then this one, when 8 slips, a slipping 8 means infinity. Sequence sometime, when it is reducing, can turn to infinity. When you are listing something and that will keep on reducing, it means that thing does not have, because you go to the negative and keep on reducing. Is that clear? So there is maybe need for you to calculate sum to infinity. We try to see how to apply this. Now let's look at the first one. The formula, this out come first before 1 when this out common ratio is greater than 0. So when you find your common ratio and it's greater than 0, you use this. This one, you look at this, a bracket 1 minus r raised by n. This case, 1 comes before r raised by n. That is when r is less than 0. Okay? Then this one is sum to infinity when n does not have, is not defined. N is not defined. That is sum to infinity. That is why you cannot see n in the formula, because n is not defined. N does the number of times does not have limits. Alright, now let's see the first question. You already know that this one is used to find any terms at any left point, any positional term in a geometric sequence. Now, look at this. Let's say I give you this. Find the sum. Find the sum of 3, 6, 12, 24. And stop there, full stop. Now this is a finite sequence, finite. A finite sequence has beginning and has end. So they said to find the sum. Now, and it is a geometric sequence. What is the first term? The first term is 3. For it to be geometric, it means it must have a common ratio. How do you get the common ratio? 6 divided by 3 must be equal to 12 divided by 6. Must be equal to 24 divided by 12. And if you look at all this, it gives us 2. Now, in this case, r is greater than 0. Can you see that 2 is greater than 0? This symbol means greater than 0. So it means I'm going to use this formula for the sum. So the sum now, according to the formula, is a bracket r raised by n minus 1 over r minus 1. Now let's substitute. My a is 3 dot bracket means, okay, r is 2. I put my 2 raised to power n. How many times? N means number of times. 1, 2, 3, 4. So n is 4. N equals to 4. Can you see that? So raised to power 4 minus 1. Everything, r again is 2. That will be 2 minus 1. Now let's come here. Please come here. This is equals to 3 dot. Now 2 raised to power 4. 2 in 4 places. That is 16. 2 times 2 times 2 times 2. 16 minus 1 divided by, what is 2 minus 1? That is 1. So that gives us 3 times, what is 16 minus 1? That's 15. If you divide anything by 1, it's that thing. So 3 times 15 is 45. It means that the sum of this, if you add this together, that is 3 plus 6 plus 12 plus 24, supposed to give us 45. Can you try that manually? 3 plus 6, 9. Plus 12 plus 24, that is 36. 36. 9 plus 6, 5. remainder 1. 1 plus 3, 4. That is 45. So you can use the formula. Now, the essence of the formula is that if it is very long, like let's say you have n being 1,000, 1,000 times or 1 million times, you cannot keep on adding like this. You've got to apply formula. But because this is not many, 1, 2, 3, 4, you can easily add it to get the same answer with this. Okay, now let's see how to apply the second formula. The next, another formula for sum. Let's try to see how to apply that. I'll try to come up with something. Look at this. Find the sum. Find the sum of 5, 2.5, 1/4, and 5/8. Again, this and you are told that this is a geometric sequence. Okay? If this is a geometric sequence, what is our first term? I will write it here. Please bring it here. Okay, let me write it somewhere here. Our first term, or okay, don't worry. Let me just work it here. Our first term is 5. The first term. This is second term. Because first term, A appear in the formula. Then we need to calculate the common ratio. Now, the common ratio is, for this to be geometric sequence, it has to be this over this, 2.5 over 5. Which is the same as 2.5 divided by 5, which is, change this to a proper fraction. 2 times 2, 1 plus 1, 5 over 2 divided by 5. Okay? Now, this will become 5 over 2. Change this to, no, this is over 1. Change this division to times. 1 will go up, 5 will come down. Now, this 5 cancel this 5. So what do we have? 1 up, 2 down. So that is half. So it means that our common ratio is 1/2. If you like, you can say this one divided by this. You can try that. Or this one divided by this. You must get the same 1/2 because it is a geometric sequence. So I want to clean this to enable me to have space. So I have not got my common ratio. How many times do you want to add together? N. 1, 2, 3, 4. So it's also 4. 4 times. Now, if you look at this R, R is half. Half means 0.5. Okay? Which is less than 0. Okay? 0.5. Okay? So, it means, greater than 1, and less than 1. Thank you. Greater than 1. That is the rules. So this is less than 1. So it means I'm going to use this formula. Xn is equals to A into 1 minus R raised by n over 1 minus R. You use this one, this second formula, when R is less than 1. I'm sorry, not less than 0. This one, you use this one is greater than 1. You use this one when it's less than 1. Okay? Now, let's see this. Let's substitute now. Our A is 5 into 1 minus R is half. Half raised to power 4. N is 4. Close the bracket. This is 1 minus half. Now, let's come here. Please direct something here. This one is equals to 5 bracket 1 minus. Now, what is the meaning of half raised to power 4? It means half times half times half times half. That is 1 over 16. 2 times 2, 4. 2 times 2, 4. 4 times 4, 16. So that is 1 over 1 over 16. Over what? 1 over 2, half. Now, what is 1 minus 1 over 16? Let me teach you a simple technique here. If you have 1 minus 3 over 7, just take away. The answer is take away 3 from 7. That is 4 over 7. If you have 1 minus 11 over 20, the answer is this. If it is 1, just take away 11 from 20. What is that? That is 9. Then over 20. So, in this case now, I'm going to use that method here. 5 into what is 1 minus 1 over 16. Take away 1 from 16. That will give you 15 over 16. Did you understand that? Okay, over divided by what is 1 minus half? The same thing. Take away 1 from 2. That will be 1 over what? 2. Okay, now this will give us, open the bracket. Don't forget that the meaning of this is this. This is 5. If you open this bracket, it means times 15 over 16. This line here means divided by 1 over 2. I want to continue this here. Are you following me? I want to continue this to get our final answer here. Do you see it? Now, the meaning of this is this. This is 5 times 15 over 16. Now, I want to change this. Bring it here. I want to change this division to times. Then 2 will go up, 1 will come down. Do you understand that? 2 over 1. Yes. So we have 2 here, 1. 2 here is what? 8. So this is equal to 5 times 15. That is 75 over 8. Okay, I want to end it here like this. Now for this one, sum to infinity. Like this number E now. Look at this. This is reducing 1 to 1 over 4 to 1 over 16. You see, as the denominator is increasing, this number is reducing. Take note of that. 1. This 1 is bigger than this. This 1 over 4 is bigger than 1 over 16. This 1 over 16 is bigger than 1 over 64. It means that this will keep on reducing to infinity. In that case, let me just tell you what we do. In that case, I think I can clean this now. In that case, okay, let's solve that. Let's solve that. Let's solve that. Let's solve that. Let's say I give you this. Finally, find the sum to infinity of 1 over 4, 1 over 16, 1 over 64. Then to infinity, that means continue, it doesn't have end. So our first term is 1. Our common ratio R will be this over this or this over this. Okay, I want to choose this 1 over this. That will be 1 over 16 divided by 1 over 4. I'm choosing this 2. Which is the same thing as 1 over 16. Okay? I want to change this to times 4 over 1. 4 here 1, 4 here 4. So this gives me 1 over 4. Now come here, look at this. So no n because it's to infinity. N is to infinity, it doesn't have n. So that is why n does not appear. So the formula is this. Sum, please the camera here. Sum to infinity is a over 1 minus r. So this is equal to, what is A? A is 1. You put 1 here. Over, this is 1 minus, what is R? R is 1 over 4. Now again, this is 1 over, what is 1 minus 1 over 4? Just like I told you, take away 1 from 4. That will be 3, then over 4. Now let us interpret this. This is 1. This line means divided by 3 over what? 4. Now change this to times. That will be 1 times, this will go up, this come down, 4 over 3. Then if you multiply anything by 1, it is that thing. So that means the sum to infinity of this number, of this sequence, is 4 over what? 3. Try to take note of this formula. With this, you have come to the end of geometric sequence. Now, for those of you that are fully registered with this platform, like I said, learning STEM without feedback, without practicing, is like you are wasting your time. It is in the practicing you will come across challenges and you'll be able to solve it. So, for those of you that are fully registered with us, practice the following. Question number 1, write the 19th term of the sequence. You use this first formula. Question number 2, find the next term in this sequence. The next term. Well, you can use this formula to find the next term. Okay, like this one, this 1, 2, 3. The next term will be n equals to 4. Yeah, you get your first term, you get the common ratio. Then finally, show if these are geometric sequence. That's number 3. Show if these are geometric sequence. For them to be geometric sequence, you have to try common ratio, this over this, or this over this, or this over this, at least 2. If you get the same answer as common ratio, that means it's a geometric sequence. But if you get one common ratio and the other one you didn't get the same answer, it means it is not a geometric sequence. With this, we have come to the end of this very important topic. Please keep subscribing, keep sharing, keep supporting. Tell your neighbors, your friends in your various school to be part of this wonderful platform. See you next time. Bye.
Alpha, make you know they bother with me. Your father, what you want?